Hi everyone. Okay, so this is going to be a review on Le Chatelier's principle. And so we're going to practice adding stress to the system and how the equilibrium will shift when we change pressure, temperature, and concentration. All right, so what you're going to do for each part, you're going to indicate which way the equilibrium will shift if you do all of these things, like cool the reaction down, add more of this, so on and so on. Okay, so remember, add away. Okay, it wants to move away from the added stress. Okay, it wants to so when you add stress to the system, like adding more concentration or changing the heat or the temperature or something like that, it wants to get rid of the stress. So it's going to move in the direction opposite of where the stress is being added. For example, the first one, we'll do the first one together. Cool the reaction down, okay? So when you cool the reaction down, you need to find where the heat is located. So in this reaction, it's indicated right there on the right-hand side of the arrow, okay? Now, if you were to add more heat, it would want to move in the opposite direction. It would go to the left if you were to add more heat. But cooling the reaction down is the opposite of adding heat. That's removing heat. So if you were to add, it would go this way. Therefore, if you were to remove, it goes towards itself. Okay? So add away, remove towards. So I say add away because both of those begin with the letter A. So that's one way that you can remember it. So then if we were to cool the reaction down, it would shift the equilibrium to the right. Okay? So go ahead and see if you can do the other ones on your own. So you should pause the video and then replay it to check your answers. So you should indicate if it's shifting right, if it's shifting left, or if there is no shift at all. Okay? If it's shifting to the right, that means that it is favoring the product side and that we have more products in the mixture than we do reactants. And then vice versa if it's shifting to the left. Okay? All right, add more hydrogen. So here's hydrogen right there, right? So if you were to add more hydrogen, it wants to move away from itself. So add away. So then that one would shift to the right. Now what would happen to the equilibrium if we add an inhibitor? Well, let's think about it. What do inhibitors do? Well, inhibitors slow reactions down, right? So then in this case, when you add an inhibitor, there's no shift. It does not favor one side over the other, okay? It just slows the reaction down, therefore reaching that equilibrium point slower. But it does not favor one side over the other. Okay, the next one, remove C2H6. So C2H6 is right there. So if you were to add more, it would go away from itself, right? So removing is the opposite, so it's going to go towards itself. So then that one would shift to the right. Now the pressure one. The pressure one, you have to think about the size of the container. Okay? So does this mean that the container is getting smaller or that the container is getting larger? Okay? So is the volume decreasing or is the volume increasing if you are decreasing pressure? So if you are decreasing pressure, you are making a larger container, right? Okay? The larger the container, the less pressure there is. So if the container is larger, it's going to favor the side that has more moles because you can fit more in a larger container. So to figure out how many moles there are on both sides of the arrow, you add up the coefficients. So then on the left, that adds up to 3. And then on the right, you don't add the heat in terms of a coefficient, so then you add up the right, and that's a 1. Okay? So the left side has more moles than the right side, so this one would shift to the left. Okay? All right, we're going to do 2 more practice sets, and let's see if you guys can get 100% on the next 2 sets. Okay, so on this one, go ahead and indicate if it's shifting right, left, or no shift. So you should pause the video, okay, and indicate which way it's going to go, and then replay it to check your answers. All right, the first one here, add N2O4. So add away. So that one's going to go to the left. Okay, this is the last practice set, so let's see if you can get all of these correct. All right, so go ahead and indicate if it will shift to the right, left, or no shift, and then replay the video to check your answers. Okay, so add more NH3. So NH3 is right here, so add away. So that one would shift to the left. All right, remove N2. So here's N2. If you were to add it, it would go this way. Therefore, remove will go towards itself. Okay, so that one's going left. Add more heat. Add away. So that is going to shift to the right. Add a catalyst. You should have gotten no shift here. Remember, catalysts will just speed up the reaction, but they do not favor one side over the other. Now the pressure one, let's think about it. Let's see, the container, will it be small volume or large volume with an increase in pressure? So an increase in pressure means that the volume gets smaller. So it's going to favor the side that has the least amount of moles. So over here on the left, this adds up to 4, and this one adds up to 2. Okay, so therefore it will shift to the right, favor the side that has the least amount of moles. Okay, all right, so that is everything. And hopefully after all of these practice sets, you understand Le Chatelier's principle a little better. And that is it. I will see you guys later. Bye.